Okay, welcome to your first set of notes on transformations. This is 1.1, and so today we're going to talk about just how to know by looking at an equation just what that does to the graph. So you can shift things, you can stretch or shrink things, there's a lot of things that you learn in geometry where like dilation, translation, those kind of things, and what they do to the graph of something. So the first thing we're just going to understand is a few vocabulary that you need to know. You need to know what a parent function is. So a parent function is the simplest form of a type of function. For example, x squared. X squared is a quadratic, and x squared is the simplest form of a quadratic is just x squared. Now, if I say 2x squared or x squared plus 4, or I add anything to it, it changes it. And that's what we're going to be talking about. But x squared is a parent function because it is the simplest form of a quadratic. The other one is called a transformation, which is what exactly we're going to do. Transformation, let me zoom in here. A transformation is a modified version of a function that causes the graph to shift, stretch, or shrink. So taking that x squared function, if we put a 2 in front of it, or we add 5 to it, or anything that we do to the function, we're going to change it. And it'll cause the graph to either shift left, right, up, down, or it could cause the shape of it to change. It could be wider or skinnier or something like that. So that's a transformation. A translation, this should be familiar from geometry, but a translation is where something can be moved up, down, left, or right. So the graph itself looks the same. It just is moved around a little bit, almost like you took your fingers and just moved it. Translations are just shifts in the graph up, down, left, or right. Reflection, again, this is another term from geometry. This is where the graph flips across the x or y axis. We don't do any reflections across anything other than the x-axis or y-axis. Now, when you get to pre-calc, they will do reflections off of diagonal lines, all kinds of different reflections that make it more difficult. And then you have the stretching and shrinking. You're going to see horizontal stretching and shrinking too, but horizontal stretching and shrinking is just the backwards of vertical stretching and shrinking. For example, a vertical stretch is a transformation that causes the graph to become skinnier and steeper. Well, that turns out that is the same thing as a horizontal shrink, because if I'm stretching something vertically, I'm also making it skinnier, which is a horizontal shrink. So horizontal movement is always going to be the opposite or backwards. So a vertical stretch will be the same as a horizontal shrink. So it's the same thing. And the same thing goes for vertical shrinks. So vertical shrinks are where the transformation will cause the graph to be wider or more flat. And that is also the same as a horizontal stretch. So they are the same thing. So if you see horizontal shrink, it's the same as a vertical stretch. If you see vertical shrink, it's the same as a horizontal stretch. I don't know if I said that backwards. But the horizontal versions of these are backwards. So a vertical stretch is the same as a horizontal shrink, and so on. So there is a couple things that you have to know here. And so we're going to work mainly with absolute value parent functions and quadratic parent functions. So we're going to go over absolute value first, and then we'll do with quadratics, and you'll see that they function the same in terms of the ways we can manipulate the equations. So first thing here is we need to show you our transformation guide. So all absolute value and quadratic functions that we are going to deal with in this class all follow this sort of guide. The red letters, the A, B, C, and D, are all places that you can put numbers that will cause either a transformation or a translation. So if I put something in A, something happens. If I put something in B, something else happens. If I put something in C, something else happens. And if I put something in D, even something else happens from there. So all these different places do different things. And so now we're going to share those with you. So what does A, B, C, and D do? Well, it turns out that anything on the outside of these parentheses, now do keep in mind, those parentheses are just arbitrary. So these parentheses right here, see if it'll let me, are just arbitrary. So if it's an absolute value, then you'll have absolute value bars here. If it's a quadratic, then you'll have parentheses, and you'll also have a little square up here. So don't think of these as just they have to be parentheses. Think of just A and D as the outside and B and C are the inside. Anything that's on the outside will affect the graph vertically. Okay, so A, for example, is a vertical stretch or shrink. It also will, if there's a negative there, will reflect the graph or flip the graph vertically as well. So A, again, is a vertical stretch or shrink, and we're going to show you examples of these, so don't worry. It's also a vertical flip or a reflection across the x-axis. But when you get inside these, you start to affect the graph horizontally. So B or C will affect the graph horizontally, whereas B is a horizontal stretch or shrink. And also, if there is a negative in here, it will reflect the graph across the y-axis, or it will flip it horizontally. C is a horizontal shift. So this means if you put something in C, it's going to move the graph left or right. I will tell you, there's a reason why this negative sign is in there. Somebody always asks, like, well, why is it minus in there? Well, because whenever you shift something in here, I put a number in for C, it's going to have the opposite effect. And I'll show you what I mean by this when we do an example. But if I put in, for example, a positive 5 for C, this minus sign makes it a negative 5. So if I think that I'm putting a positive 5 and it's going to move to the right 5, the negative actually turns it around and goes left. So a positive 5 actually makes it go left 5. It's weird. It's opposite. I know. If I do a negative 5, the double negative makes it positive. So a negative 5, which you would think would make the graph go left 5, actually makes the graph go right 5. So I'll show you that. And then there's D. D is a vertical shift up and down. Now this one has a plus sign, so it's not affected by anything. So if you were to go up or down, it goes the appropriate way. So a positive 5 means it does go up 5, and a negative 5 means it does go down 5. Because the plus sign is here, it means that whatever it is, it doesn't get changed. Okay, so let's look at some examples. Now that we have that, you may need to scroll up and refer to this. That'll be good for quizzes to have that on your notes guide. But let's look at an example. So the first one we're going to look at is the absolute value. That is what a base absolute value looks like. This is the parent function for absolute value. It's just the absolute value bars with an x inside. Okay, so you'll notice that you have a perfect sort of line here at a 45-degree angle going up with a slope of 1, up 1 over 1, up 1 over 1, and it goes in both directions. That is a standard absolute value, just x in the parentheses. Now, if we add things to it, we can make this graph move around, left, right, up, down. We can make it flip. We can make it stretch or shrink, all that. And so we're going to look at that. So what you need to be able to do is look at an equation and be able to pick out what letter did it change. Which one of these letters was adjusted, and then you can figure out what's going to happen to it. And then you can put the graph in your graphing calculator or into Desmos to verify that you got this right. So when we see this here, f of x is the absolute value of 2x. So what we have here is we've added a 2. We've added a 2 into this function. So what letter is that? Remember that the outside over here is A, B, C would be something that's added or subtracted, and D would be on the outside. So what you actually have is B. You would put a 2 in that B spot. And B, if we remember from up here, B does a horizontal stretch or shrink. Now, horizontal stretch and shrinks are the same or opposites of vertical stretches and shrinks. So when you add a 2 in there, that is going to be a horizontal shrink. Okay? It's opposite. I know. You think of 2. Like if it were 1/2, you would think that that would shrink it, but it doesn't. It has the opposite effect. Anything that is inside of these bars or parentheses, if it's a quadratic, does the opposite of what you think it would do. So you would think that a 2 would be a stretch because you're making it larger, but it's not. It's actually a shrink, and I'll show you what that looks like. So what this is a horizontal shrink by a factor of 2. Horizontal shrink is the same as a vertical stretch. So you're going to see that it's going to get skinnier and it's going to get steeper. So I want to show you this in Desmos. So if we look at Desmos, there is your standard absolute value. Now if I put in a 2 for B, so here's B, I'm going to put in a 2 and you'll see how this changes. So take a mental picture, and now what if I change it to 2? Okay, notice how the graph has become skinnier, the lines have become steeper. That is just like a vertical stretch, which is opposite, which is a horizontal shrink. Okay, you can use Desmos or your graphing calculator to verify that what you said is in fact true, and I recommend doing that. Let's just show you 1 there, so we can change that again. 2, 1, 2, 1. So you can see that change. Okay, so what it ends up looking like here is that. So we've made it skinnier, steeper. That is a horizontal shrink, or the same as a vertical stretch. Now, we look at number 2, or well, the second problem here. You will see that we've added 2 things. We've added something on both the outsides. We've added something on the outside on the left, and we've added something on the outside on the right. So we have to look up here, okay, what is outside left and outside right? Well, okay, outside left is A, outside right is D. So we've changed A and D. So what we have is A and D. Now, A and D will both affect it vertically. A negative A will flip the graph. So normally an absolute value looks like a V, but if you put a negative out front, it's going to flip that V upside down, okay, across the x-axis. And then the D is a vertical shift. So what we have is it is shifted up 1. Now we can verify that we got this correct. Is it flipped and is it shifted up by 1 by checking it in our graphing calculator or Desmos. Now remember, on a test or something, you can't use Desmos. So know how to do it in your graphing calculator. Desmos is a little bit easier to work with. But if I put a negative for my A, so -1, notice how it's now upside down. And if I put a D as a +1, it goes up 1. So it is in fact true that it does flip and it is shifted up by 1. So I did get that correct, and that's what you would put. Try the other ones here. This one has 3 things added to it. It has an A, a C, and a D, so a lot going on here. The A is on the outside, so that is a vertical stretch. So you'll see that will make it steeper or thinner. It's going to be more sharp and not as flat. It'll be taller. The C is a horizontal shift. Remember that this is backwards. So you're going to think that -2 or -2, a horizontal shift, that's going to go left 2, but because remember, if it is inside these bars or parentheses, everything works opposite of what you think it would do. So this is not a shift left 2, it's actually right 2. And so we'll verify that. And then on the outside, a -3 means it's a vertical shift and then going down 3. So this is what we have, a vertical stretch by a factor of 2, horizontal shift to the right 2, and a vertical shift down 3. So let's verify that and make sure we have that correct. I'm going to go over here and put this into Desmos so we can see we've changed our A. So let's make that 1 so you can see what it looks like. We've changed that to a 2. Yes, it is in fact skinnier. It is a vertical stretch. We've made the C, it's -2. So notice how when we do -2, it actually, because the minus is already there, that's going to change that. If I put C as 2, the reason I do C as 2 is because the minus is already in the function. So it is actually a -2. But notice that it went right to 2, or right 2. And then D was, I don't remember, what was D? -3. So -3 does in fact go down. So yes, it did get thinner, or skinnier, stretched. It's a vertical stretch. It did go right 2 and down 3. So that is in fact true. Okay. And the last one, this one's pretty straightforward. Only one thing was added to it. So you just have the 5 added to it, which is C. Remember, whatever's in there is going to do the opposite of what you think it will do. Okay. +5 is a horizontal shift, but it's not to the right 5. It's actually to the left 5. And you can check and verify it if you want. The last one is kind of crazy. I'm not going to do that one. That's a quadratic and a absolute value. That's above where you need to do. So I'm not going to have any problems like that. So I crossed that out. So the last one here we're going to look at is quadratics. We're only going to do a couple here because they function exactly the same. Whatever you do in absolute value is the same thing that you would do here. So, and actually, you're not going to see any of the ones. So, technically, these first 3 here are shifted, but it's way more difficult to figure out just by looking at it what happens. So, you're not going to have any questions like that, but if you did have questions like that, my recommendation would just to graph it and see what happened. So, put in x squared and then put in those functions to see what happened. So did it go left, right, up, down? Did it get stretched or shrunk or whatever? Because there's no real easy way to tell just by looking at it. It has to make it easy to look at, it has to look like this with the parentheses and everything. So these parentheses here act the same way that the bars do. So this is the outside, this is the inside, and this is the outside here. So here you would have A, B, C, and D. Well, we don't have a B and we don't have a D. So what we have here, just that negative on the outside and the 3 on the inside, all we have is A and C. Same exact transformations happen here. So the negative on the outside will flip the graph upside down. And then this 3 on the inside does not, it's a horizontal shift. It does not move it to the right 3. It actually moves it to the left 3. So vertically flipped and a horizontal shift left 3. We can verify that by putting this into Desmos. Now I'm going to flip off of absolute value and change this to the quadratic. Let's put everything back the way it was. That wasn't the way it was. This is the way it was originally. So you can see there is our basic quadratic function. Okay. Now, there was a negative for the A, so I'm going to change this to -1, so you'll see it will flip upside down, and then this was a +3 on the inside. Now, to make this positive, because in the equation, it's got a minus already there. We have to put -3 because then that will act like a +3 because the double negative. So you'll see that the graph did flip and then move left 3. So we did get that right. And the last one here does have the 1/2 on the outside. That is a vertical shrink, making it flatter, wider. The -1 there is not going to shift it left 1, but right 1. And then there you have A, C, and D. And then the 1 on the outside will shift it shift it up 1. So vertical shrink, shifting right 1, and then shifting up 1 for the outside. And you can plug that in and verify that as well. So we're going to do a couple example problems now, just so you can see this. What you're going to have to do, like on a quiz or something like that, is identify the parent function and then identify what happened to it. So this is more just a visual. So it obviously with the V-shaped, this would be an absolute value. So the parent function would be y equals the absolute value of x. That is the parent function or function family. And because this 5 is right there, that is going to be a horizontal shrink. Okay, it's opposite. You'd think 5 being bigger than 1, it would be a stretch, but it's not. It's actually shrink. It's opposite, remember? So this would be a vertical stretch, and you just write vertical, pardon my handwriting, stretch by a factor of 5. So that's it, pretty straightforward. This one, obviously being a U-shaped, is a quadratic, so the parent function is just x squared. That's the basic quadratic. Here you can see, based on the equation, what has happened. It has been, because of the -1, it actually moves right 1. Remember, it's opposite. So right 1, oh my gosh, right 1. And the +4 has caused it to go up 4. And you can see that in the graph. And that's all you do with those. You'll see those on a quiz too, just like that. Last ones, this is it down here. This here, you're going to graph the parent function and this function and describe the transformation. So with a quadratic, this is a quadratic. So it typically starts here. And then, I know this is going to throw you off because it goes by 2's, but 1, 1 is a point on the regular quadratic. And then 2, 4, so it looks like this. And then 3 is 9, so it looks like this. This graph's weird because it goes by 2's. So this is what a traditional parabola will look like. By the negative being out front, I know that that is going to flip the graph. It's going to flip it upside down. So my transformation, change colors here, is going to be the exact same thing, just upside down. Okay, there's a transformation, flipped vertically. With a 1/8 out front, this is a quadratic again. Let's change this. So a quadratic again, same thing. It's going to look like this. This is the standard quadratic. All I'm doing is just plugging 1 in, and what do you get? 2 in and 3 in. 1 is 1, so 1's there. 2 is 4, so 2, 4. 3 is 9, so I put it up there, and that's how I get the quadratic, the standard quadratic. 1/8 is not going to flip it just like the last one. It's going to it's going to shrink it. It's going to be by a factor of 1/8. So you can get your points by just plugging numbers in. So 1 squared is 1 times 1/8 is 1/8. So 1 is 1/8, which is really low. 2 squared is 4. 4 times 1/8 is 4/8, which is 1/2. So that's like right there. Let's do a bigger number. Let's do 4. 4 times 4, 4 squared is 16. 16 times 1/8 is 16/8 or 2. So 4 is actually 2. And so you get this, and you could just put a mirror image of these on the other side. So notice how it's wider, it's flatter. The 1/8 is a vertical shrink because it's less than 1. And so you see it get wider like that. Same thing here. This is an absolute value though, so we'll change key or change colors. The regular absolute value goes linear, up 1 over 1, up 1 over 1, up 1 over 1. So there's your standard absolute value. By putting a +1 on the outside, all it does is shift it up 1. So I know these go by 2, so it's a little weird. Here, I'm going to try to draw this one a little bit better. There you go. There you go. So that's just absolute value. It's just been shifted up 1. So that's transformations. It's everything you need. Thank you very much, and let me know if you have any questions.